New pictures from the James Webb Space Telescope have staggered experts. Rather than extending how we could decipher the universe, these photographs uncovered a disturbing reality. Our nonstop discernment is missing to make heads or tails of the opportunity of the universe in its early phases. Where the hypothesis of the universe's early phase shows up at its limits, this urges us to ponder new theories about its beginning. The request arises concerning how the universe was formed broadly and why this new disclosure challenges even the most experienced space specialists to sort out more about the huge explosion and the strong nuances of the revelation. We ought to overview the opportunity of the enormous detonation itself rather than famous thinking. The enormous detonation was not an impact in prior space. Rather, it was space itself that started around 13.8 quite a while back, close by issue and time. From a surprising eccentricity in veritable science and cosmology, this peculiarity depicts a state where gravity is outrageous to the point that the state of room-time becomes boundless. Today, following billions of years starting from the beginning of the universe, we see that our colossal home is important for a basic correspondence for subject matter experts. This tends to an essential piece of the universe, as its actual presence and its clearly interminable extension are indispensable to appreciate. The universe isn't meandering into prior space. Rather, space itself is ceaselessly loosening up in size. As per conventional hypothesis, the main star started to sparkle somewhere close to 200 and 300 million years after the enormous detonation, denoting the completion of the supposed dull age. This was the point at which the primary radiant heavenly articles bunched together to frame mature worlds. In any case, the way that quickly these frameworks created stays an unbelievable riddle. An enormous snippet of data arose through the principal pictures got by the James Webb Space Telescope in July 2022. Very much educated specialists revealed that the telescope had distinguished different cosmic systems, some of which had proactively existed around 300 million years after the advancement of the universe. Nonetheless, contrasted with the huge systems that shaped billions of years after the fact, these early universes were essentially more unassuming and less monstrous. This fits impeccably with the logical model acknowledged by trained professionals. The thickness of issue in the early universe was essentially not adequate to prompt cosmic systems the size of those noticed today. The revelation of 6 stunning redshifted radiant spots from the James Webb wound up setting off one of the really cosmic crises of late times. Notwithstanding the way that these recently found worlds are comparable in age to as of late recorded universes, they are almost basically as gigantic as our own smooth way. This has made a dazzling secret in galactic science. In the wake of looking at a progression of pictures caught by the close infrared camera, experts recognized the previously mentioned light sources utilizing redshift analyzers. They affirmed that the light from these articles required more than 1 billion years to arrive at our eyes on the planet. Accordingly, we are managing structures that had recently existed somewhere close to 570 and 700 million years after the affirmed enormous detonation. By taking a gander at the qualities of these worlds, it was reasoned that the Webb telescope had caught 6 early cosmic systems in the pictures. Unbelievable as it might appear, these universes were gigantic to the point that they opposed regular suppositions of cosmology. Rather than finding the standard Bantam universes, structures were distinguished that were almost pretty much as extensive as our own smooth way, regardless of having shaped from the get-go in grandiose history. Assuming we keep on investigating the information accumulated by the James Webb Space Telescope, this gravitationally bound assortment of stars was at that point in excess of 10 billion times the mass of the Sun around then, with one perhaps amazing event being 10 billion Sun-powered masses. In any case, whether this chance is thought of, the secret isn't completely settled. Indeed, even in that situation, there would be fundamentally more mass in the early universe than recently expected, introducing a problem. The distinguished articles conflict with essentially all traditional cosmological speculations. Whether or not only one of these frameworks turns out to be affirmed, it would provoke our past suppositions to make sense of the presence of these designs. Also, the thickness of issue in the early universe should be a few times more noteworthy than recently perceived to represent this trademark. Another likewise weird clarification relies on the likelihood that these systems shaped in a way that is still totally murky to us. These disclosures and the conversations they incite about the huge explosion lead numerous experts to move away from this speculation. Various space experts with elective perspectives are confounded, and their viewpoints are much of the time heard in logical diaries. Indeed, even the people who express questions about existing hypotheses are as often as possible marked as unconventional. Notwithstanding, obviously, even researchers who actually protect the theory of how things came to be are consistently stood up to with questions lacking conclusive responses. These inquiries incorporate explicit issues, for example, why and how, 13.8 quite a while back, something in a real sense rose up out of nothing. Might something really have begun from nothing? Or was there some setting-off occasion? Or was it all an occurrence? Stephen Pedling brought up that the idea of time as far as we might be concerned started with the huge explosion, and accordingly this cycle would never have been set off by something different or by an outside clarification. A correspondingly puzzling request connects with the consistency of radiation and thickness all through the universe. Despite which heading or at what distance we look, on a bigger grandiose scale, we track down comparative densities and disseminations of cosmic systems, nebulae, and radiation all over. Ordinary specialists make sense of this unpredictability through the hypothesis of infinite expansion. In any case, different researchers broaden this speculation further with a hypothesis of turbulent expansion. As per this thought, expansion has just stopped in unambiguous districts, similar to air pockets, and go on enthusiastically somewhere else. This proposes that various universes could shape in these air pockets, each with its own extraordinary actual regulations. Inside this model, a significant inquiry emerges. Imagine a scenario where the universe doesn't address the total. All the more inventively, consider the possibility that one more universe existed before our own. All things considered, the enormous detonation would turn out to be essential for a bigger cycle. As per this viewpoint, our universe is essential for a bigger complex design. Inside this model, the chance of an undying pattern of rot and resurrection of the universe is progressed. Notwithstanding, this isn't the main point of view presented in the domain of cosmology. Beside the speculation of how things became, in 1955, for example, an article showed up in NASA's Huge Times contending that there could have never been an enormous detonation since the universe has existed for an everlasting period. In this view, the advancement of the universe would be non-existent, and the ceaseless improvement of issue could give the impression of combined development. Additionally, another fascinating and dubious hypothesis emerges from the domain of quantum material science and string hypothesis. A few examinations have proposed that our universe and all that in it likely could be a projection or a higher layered recreation. While this might seem like the plot of an unusual science fiction film, it very well may be associated with the Kardashev scale, which estimates the degree of improvement of a development in view of its capacity to tackle energy. On the off chance that there were a Sort 3 civilization able to do totally using the energy of a whole cosmic system, it could have made an ideal reenactment. Nonetheless, understanding reality in such a situation is a profoundly complicated matter. Researching the profundities of cosmology and the starting points of our universe leads us into a domain of critical secret and progressing logical request. The new pictures caught by the James Webb Space Telescope have reignited conversations about the actual texture of our reality, moving laid-out hypotheses and provoking scientists to reevaluate key parts of cosmological comprehension. At the focal point of this request lies the hypothesis of the universe's starting point, a foundation of current cosmology. As per this hypothesis, around 13.8 quite a while back, the universe rose up out of an extraordinarily thick and hot state, extending quickly and bringing about space, time, and matter as far as we might be concerned today. This giant occasion was not just an impact inside earlier space, but instead included, unequivocally, the start of room itself. The idea of a peculiarity, where gravitational powers are serious to such an extent that space-time bends vastly, upholds how we decipher this beginning stage. However, the revelation of early systems by the James Webb Telescope difficulties are suppositions about how rapidly structures framed in the universe's earliest stages. These worlds, distinguished inside a couple 100 million years of the enormous detonation, show up shockingly progressed and gigantic when contrasted with flow cosmological models. One of the key inquiries raised by these discoveries is the possibility of vast expansion. As indicated by the overall hypothesis, expansion happened inside parts of a second after the huge explosion, making the universe grow emphatically. This quick development would make sense of the consistency of the astronomical microwave foundation radiation saw across the universe today. Nonetheless, current discoveries recommend intricacies in the early universe's advancement that might expect acclamations to inflationary models. The rise of systems, similar to those seen by the James Webb Telescope, urges cosmologists to rethink the circumstances and cycles that administered the universe's initial history. These universes, presently tremendous in size and mass not long after the enormous detonation, propose a thickness of issue that surpasses past estimate. The ramifications of these revelations stretch out outside our ability to grasp of the early universe. They challenge the major suppositions about the development of worlds and the job of dull matter and dim energy in molding the universe. As analysts dive further into the attributes of these early worlds, they plan to disentangle the intricacies of their development. The startling mass and size of these designs could demonstrate that the cycles of world development were more effective or fast than current models propose. This acknowledgement constrains researchers to reevaluate the systems at play during the universe's earliest stages, including the impact of dull matter, which is accepted to represent a critical piece of the universe's complete mass. Besides, these discoveries likewise brief a reassessment of the job of dull energy in the extension of the universe. As worlds shaped before and more enormous than expected, it brings up issues about what dull energy has meant for their development and conveyance. The collaborations between dim matter and dull energy could give bits of knowledge into the development of the universe, assisting with explaining how these powers molded the universe we notice today.